jumping into chapter 2 today. And chapter 2 is all about functions. So specifically today it is relations and functions. So the first part of this we are going to be going through and just going through some basic vocabulary definitions, but a lot of what you're seeing today is definitely review. It's not all of it really. So a relation, first word up there. A relation is a set of pairs of inputs and output values. So a lot of what we're going to be working with today are sets of ordered pairs. And so a set of ordered pairs is known as a relation. Whether or not it is or is not a function, it's a relation. Domain and range. Familiar vocabulary words? What do you remember about domain? X. Okay, so domain are the X's. We could also think of them as the inputs, the input values, or when we look at an ordered pair, they are the first number in the ordered pair. Okay, so if domain are the X's, what's range? Range are the Y's, also known as the output values or the second number of the ordered pair. Okay, definition of a function. Okay, official terminology here. A function is a relation in which each element of the domain corresponds with exactly one element of the range. In short, the x's don't repeat. Okay? I always say it as each x pairs with exactly one y. Okay? If you have an x that is paired with different y's, then that makes it not a function. But the short of it is, the x's don't repeat. When we start talking about whether or not something is or is not a function, we can look at those x's and decide. If we have a graph, we tend to use the vertical line test. You remember the vertical line test? Vertical line test, you draw a vertical line, and as long as it only crosses the graph in one location at a time, it still is a function. If you draw a vertical line and it touches the graph twice, or more than twice, it is not a function. It fails the vertical line test. And we'll practice that, okay? We're going to practice all this stuff. Function rule. A function rule is a fancy way for saying the equation. A function rule is an equation that represents an output value y in terms of an input value x. So, when we see function rules, often instead of y, you'll see f of x. You remember f of x where it's f parentheses x? Read f of x, that's standard function notation there, which is what the next line talks about. Function notation is when y is represented as f of x. So when we talk functions, there's usually x and f of x instead of x and y. And then lastly, independent and dependent variables. Okay, the independent variable, notice here it's the x. The independent variable is the one that can exist on its own. For instance, time. That's a common independent variable because time just exists. We don't start or stop time or anything like that. It just exists on its own. It doesn't need any help for anything else. Whereas the dependent variable then, maybe that's height. Well, the height of an object depends on where you're at time-wise. You know, has 1 second passed, 2 seconds passed, so on and so forth. And so, independent variable is the x. Think horizontal axis. Whatever's on the x-axis is your independent variable. Whereas whatever's on the y-axis is your dependent or y variable. So again, just some vocabulary to get us started here. Okay. Example 1, we're going to talk about domain and range. What are the domain and range of these relations? So let's start with A. There are a bunch of ordered pairs there. I'll be honest, I'm going to take the easy way out. I'm not reading off those ordered pairs because it's time consuming. There's big numbers in there. You have them in front of you. Thoughts on what the domain is? Okay, all the first numbers, because domain are the x values, right? So it's the first number in each parenthesis. So when I list my domain, first of all, I'm going to use what's called a brace. It's kind of like a squiggly parenthesis. Do your best to draw it. Okay? What are my specific domain values for this problem? Okay. 0, 4, 8, 12, 16. And that's because in an ordered pair, it's always x, comma, y. So the x is always the first value. Now, if those are my domain values, what about range? Okay, all the second numbers, right? All the y values. In this case, all the big numbers. Okay, what is that? Well, first of all, I'm going to start with the brace. What's that first range value? 10,000. What's the next range value? 9,744. Next. 8,976. 7,696. 5,904. Okay. You've been there, done that with domain and range before. I'm not introducing anything new. And if I am introducing something new, then you probably weren't very successful in Algebra 1, I'm guessing. Or you were absent for that entire chapter, or I don't know. So you guys have, and I say that because Algebra 1 was not even the first time you saw this. I know I taught it in middle school when I taught middle school. So, okay, let's go ahead and do B real quick. I'm just going to use D for domain. What are you thinking about the domain on B? What? Okay, all the x's. Someone want to specifically give those to me? Other than Jameson?
-3, 0, 2, 9, 23.
Okay. -3, 0, 2, 9, 23 are your domain values. First number in each ordered pair. What about the range value? And it can't be Jameson, it can't be Kenzie.
14, 7, 0, -18, -9.
Okay. 14, 7, 0, -18, -99. All the y values, right? Okay. Nothing tricky there. You're all good? Okay, so we've covered domain and range here. Now we're going to start talking about, is the relation a function? Okay, the first, in problem 2, we're looking at some mappings and then some ordered pairs. When we get down to problem 3, we'll talk about graphs. Are you guys familiar with the mappings type situation? It's the idea that each number in the first bubble, or a bubble's not probably the right word there, but whatever the right word I should use there, but each number in the first grouping is paired with some number in the second grouping, right? And it's just following the lines. So in this case, we would have -3 pairs with -2. 0 pairs with 7. And 4 pairs with 1. So that mapping represents those 3 ordered pairs. Is this relation a function?
Yes.
Why yes?
Because none of the x's have the same one.
Okay, none of the x's have the same y. Each x has one and only one y, right? And, or if you look up above, the x's don't repeat. That's the easiest thing. So I'm going to write that yes, this is a function. Okay, what about B? We've got another mapping there. What? He says no. Why? Okay, one number went and ruined it, didn't it? Number 2 pairs with? Yeah, so we have ordered pairs of 2, -3, and 2, -1. Right there is the problem. The fact that 2 is paired with 2 different y values. It's only allowed 1. And so because of this, it is not a function. And I don't care if you write no, not a function, however you write it, as long as you get the idea across. Okay, what about C? We were at a list of ordered pairs. Function or not a function? Madison, you're shaking your head no. Why'd you say no? Okay. 4 goes with -1. Later on, 4 goes with +1. Are -1 and +1 the same number? Kind of a silly question, but I have to ask. They're not. So this is not a function. And that takes us to D. More ordered pairs. Function or not a function? What was it? Function? Why do we say it's a function? Yeah. I have 4 unique x's here. -7, +9, +14, +7. Each x is different. So this one is a function. Okay, we got a grasp on function versus not a function? Okay. So let's talk about graphs. In my mind, these are kind of the fun ones. I say fun because it's easy. Fun math and relates to easy math. That's, I feel like how you guys have the viewpoint there. So, okay. Determine whether the following graphs are functions. What are we going to use here? Vertical line test. So if you're sitting there thinking, whoa, graphs, these aren't going to be easy. Vertical line test, guys. That's what we're going to be looking or using on this section. Is a vertical line test. So, talk to me about how the vertical line test works there on graph A. It doesn't? Well, it works. I mean, we can use the test works, but what's the results of the test? Not a function because what happens? Okay. I just picked a random spot and drew a line. What do you notice about the line I drew? Yeah, it's a vertical line, but it crossed my graph 2 places. And there's other places you could draw a line and it crosses the graph 2 places. As long as there's even one spot that you draw a line and it fails the vertical line test, the whole thing fails. So this is not a function. Graph B. Kinsey says it is a function. Do you agree? Well, let's see. Let me try. I could draw a line there. It only crosses once, right? I can draw another line there. Only crosses once. I can draw a line there. Only crosses once. Is there any place I can draw a line that's going to cross twice? No. So this one is a function. C. Olivia, you're shaking your head no. Why not?
I don't necessarily know why, but I feel like because the dog.
What gave you the notion to say no? Go with your gut here.
Draw a line.
Okay, if we draw a vertical line, are there any places that are going to fail the vertical line test?
Oh,
Yeah. There's only one vertical line that's going to fail me. But there's a vertical line that fails me, yes? As long as there's a vertical line that fails me, then this fails the vertical line test, and it is not a function. We don't know what those ordered pairs are. But what I do know is when two ordered pairs are stacked on top of each other, they're going to have the same x value. Because you had to go over so far right the same distance to get to those x values. Okay? So that's why you always have to check every place, because one bad spot will make it not a function. D, we got a circle. Is that a big no?
Yes.
We can all agree there? I mean, right there, there's the line I drew. Whichever line you draw, this one is, again, not a function. One last graphing example. Okay. So let's see, if I draw a line here, it only crossed once, right? What if I draw a line over here? Crosses once. If I draw it over here, is there any place you can draw a line and it's going to cross that graph twice? No. So this one, yes, it is a function. Okay, get what you need from the front side. Again, I hope some of this stuff is seeming familiar to you. It definitely should. On the back side, problem 4. For f of x equals negative 2x plus 5. What is the output for the inputs? Negative 3, 0, and 1/4. Okay, they got in all these fancy words. Interpret the words here. What is it they're asking? That's the key here. Is what is it that they are asking? Okay, he says, what are the y values? Okay, so the question is, what is the output? So what is the output? Those are y values, right? If the inputs are, well, what does input represent? X. So what are we doing? We're plugging those values in for x. I'm going to set up an XY chart or a T chart just to kind of put all my answers in the same place. I'm still going to go through and show my work. XY chart, or actually what I'm going to label is X and f of x. Okay, they talked y. They said we have to find y. Well, technically it doesn't say y here. Technically we're finding f of x if you want to be, particular. Because it never actually says, there's not actually a y in the problem. It's f of x in the problem. So, those three numbers they gave me, negative 3, 0, and 1/4 are my x values. So let's take our turn in our practices plugging them in. So if I'm going to plug negative 3 in, it goes in place of x. Now, for notation purposes, it means I'm finding f of negative 3. which means I'm going to do negative 2 times negative 3 plus 5. Aunt Sally's talking to you, right? PEMDAS? What do we do first? Multiplication. Yes. Here? Yes. Yes. That is equals. Just the idea that we're finding f of negative 3. So negative 2 times negative 3 plus 5. You said to multiply. Negative 2 times negative 3 is 6. And 6 plus 5 is 11. So we just found f of negative 3 to be 11. So that means when my input is negative 3, my output is 11. Repeat the process, but this time we're using 0. So I'm finding f of 0. Negative 2 times 0 plus 5. Negative 2 times 0? 0. 0 plus 5? 5. So now I found f of 0 to be 5. Or in other words, the ordered pair, 0, 5. Okay, lastly, we're going to do your favorite one, right? We're going to plug in 1/4. That means we're doing negative 2 times 1/4 plus 5. How do I do negative 2 times 1/4? Okay, so he went decimals on me. Negative 2 times 0.25. The other option, and that's what I was going to practice, is you can leave it as fractions, and that 2 over 1. So negative 2 over 1 times 1 over 4. And both ways will get us there. Okay, I'm not, both ways work. Some of you guys are just going to multiply straight across if you do this, aren't you? 2 times 1 over 1 times 4. Oh, and I forgot negative times positive. So that's going to be negative 2 over 4 that you'll have to reduce. Or, I'm a big proponent of cross-canceling, in that 2 and 4 can both divide by 2. 2 divided by 2 becomes 1. 4 divided by 2 becomes 2. And so then I just multiply here, 1 times 1 over 1 times 2. I have 1/2. Any way you go about it, you're going to be getting negative 1/2, right? And now, negative 1/2 plus 5. Here's what I'm thinking. If I have $5 in my pocket and I spend half a buck, 4.5, right? I mean, you can go all fancy and you can use a calculator, you can go in fractions, but it's 5 take away half a dollar. $5 take away half a dollar. You're at 4.5, right? Now, I think Jameson actually said 4.5. Okay, there's a chance Math Excel would accept 4.5, right? Would Math Excel accept 4.5? I don't think so. I don't think, very rarely, if ever, do they accept mixed numbers. What would they accept, though, fraction form? Improper. 2 times 4 is 8, plus 1 is 9 over 2. So what I would say here is 9/2. Now, you guys have worked with Math Excel before, right? There are times they will only accept a fraction or only a decimal. So maybe you went decimals on this problem, but Math Excel will only accept a fraction. Then you have to make it work, right? But I don't think they ever accept a mixed number like 4.5. Now, I say that, and something's going to happen, and they will on this one random problem or whatever, but okay. Questions on this? Okay. B, I'm not going to write out as much work, but we'll at least talk our way through it. I'll write out some, but for f of x equals negative 4x plus 1, what is the output for the inputs of negative 2, 0, and 5? What are negative 2, 0, and 5? The x's. It calls them inputs, so that means they are my x's. Negative 2, 0, 5. Taking those and putting them into the equation, right? So the first one we're finding is f of negative 2. Every place you see an x, replace it with negative 2. Negative 4 times negative 2? Plus 1? 9. Okay, put in 0. Negative 4 times 0. 0. Plus 1? 1. I'm just repeating, putting the same number in. I just didn't write it down, okay? Put in 5. Negative 4 times 5. Negative 20. Negative 20 plus 1. Negative 19. Okay, you can write the work down. But again, I'm just putting the basics here. Okay, questions on that section? Okay, I do want to take a moment and look at these word problems. I know there are times that I skip word problems. You've already seen that because we run out of time and stuff. But you've also got to realize these are important here. So, tickets to a concert are available online for $35 each, plus a handling fee of $2.50. The total cost is a function of the number of tickets bought. What function rule models the cost of the concert tickets? And I'm going to ignore that last part for a moment. We'll evaluate later. What they are asking right now is what function rule. What does it mean it wants me to do if it's asking what function rule? I'm looking for what? The equation. Simply put, I'm looking for an equation. Let's pick some variables. What do I need variables for? What are my unknowns? Okay, so to write our function, we don't know how many tickets, right? We'll talk about this for they give us later. But number of tickets. So for tickets, I like to use T. So I'm going to say let T equal the number of tickets. What else goes into this equation? Well, before, what other variable, though? What is the other part of this that I don't know? I don't know the number of tickets. Yeah, we're going to be trying to find the cost, right? Once we know the number of tickets, we can find the cost. But the other thing I need a variable for is total cost. So I'm going to use C. C is the total cost. Now, in all honesty, could you just use X and Y? You can. So think about an equation here. This goes back to the first sentence now. Tickets to a concert are available online, $35 each, plus a handling fee of $2.50. How do I do that?
Plus 250 times T equals C.
Almost. What does the T have to multiply by? That's the question. Okay, so 35, we have to pay $35 each time we buy a ticket, right? So we have to have 35 times T. What about the 250? Am I paying 250 every ticket?
250.
Okay, and it kind of depends on the problem, right? Because sometimes you do pay $250 for every ticket. I hate buying tickets online because they are so incredibly expensive because all the fees. I know. It comes down to, it's an older example that I haven't updated. That's what it comes down to. Yeah. Yeah. So, okay. So, and that's where you have to be careful about where we put the T. The T represents tickets. So we're going to put that every place we have to do it every time for tickets. So we have to do $35 each ticket. So there has to be a T there. The way this particular problem reads, it's plus a handling fee of $250. It doesn't say $250 each ticket. So, hey, take the good deal as you can, right? So we're going to do this. And I think Alyssa had said equal C at the end. I'm going to put my C at the beginning. Doesn't really matter. And I'm fine with you guys just saying C. But to go with function format, I'm going to make it C of T. So C of T equals 35T plus 250. I'll give you a moment to write it down. I'll make sure you guys are okay with that. Would C equal say the same thing? It essentially does. Okay? But function notation generally goes with that C of T. I'll be honest. If you did C equals on the test, I'm not going to count against you. Okay? And so right there, that is one of the things you were asked to do. Write a function rule. Now, I told you to quit reading earlier. Go back and read that part that we skipped over. What do we still have to do? Yeah, evaluate. Evaluate for 4 tickets, so plug in 4. So I'm going to say C of 4 is 35 times 4 plus 250. 35 times 4? 140. 140 plus 250? $142.50. Okay, it's not a fancy equation, but it's still good practice. Some of you run away from words, period, in math, so I don't want you to. I want you to at least attempt them. Let's do one last one. This time you're buying bottles of sports drinks for a softball team. Each bottle costs $1.19. What? Notice what it says. Function rule models the total cost of a purchase. We'll evaluate for X number of bottles later. Okay. What do I need variables for? Okay, so first of all, eventually we're going to be evaluating for 15 bottles. That's eventually. So I need something for bottles. I'm going to use B for bottles. You can use something else. Just learn in math. Be careful how you make your B's so they don't start looking like 6s. I know my B's and 6s tend to look alike if I don't. I'm specific about how I make my B's here so they don't. What else do I need a variable for? Yeah, the number, because it's what function rule models the total cost. So I'm going to say let C equal the total cost. Okay, with that in mind, how do I find the total cost? Each bottle is $1.19. For my function rules, how many bottles am I buying? Not yet. I said B. Okay. So we're doing 119 times B. Are there any other costs involved? No. So that's going to equal your cost, your C. So I'm going to say C of B. If you just want to say C, you can. That is my function rule. And finally, we were evaluating for what? 15. So 119 times 15. You might actually want the calculator for that one. Unless someone's really got the mental math going, but. What? Check again. I like that answer better. Okay. 17.85 as in $17.85. Okay. Your homework is in Math Excel, lesson 2.1. You have about 7 minutes of time. I know it's not a lot. I know you really can't get a whole lot done. However, minimum expectation requirement. Please take a moment, log into Math Excel, and make sure you can get into Math Excel. As in, make sure you didn't forget your password, make sure you didn't forget your username. Make sense? Because I don't want to listen to the excuses of, oh, I got home and I couldn't get logged in last night. I'd rather get that taken care of right now. And some of you are good because you just saved your information and it's set to log you in again. Some of you are not.